Hey, it's Coach T again. This is one of the quick code videos for Python. These videos are aimed at adult or maybe adolescent learners who are struggling with some of the foundational concepts in Python, but they want to jump over those hurdles and get programming. So if you like this kind of head-first approach at one topic at a time, that's hopefully in a very digestible, straightforward, practical format, consider doing the subscribe and all that doodad stuff. But with that said, we're just going to focus on a single operator today, the floor division operator, which is a little bit weird. If you're mathematically inclined or you are used to doing a lot of division, you probably know that a lot of the times we have decimals, or we can represent the remainders with fractions. Or if you watched the last video, you know that we have something in Python and many programming languages called modulo, which reports the remainder. Well, the floor division operator is kind of the exact opposite of that, and that's why I wanted to talk about them in this order. The floor division operator shows us exactly how many times these two things can be divided into each other, but it doesn't report a decimal, and it doesn't report that shouldn't be there. It doesn't report a remainder or a decimal. So all it gives you is an integer, or the floor of that division process. You don't know if it's 5.99999, and normally we just round to 6. With a floor division operator, you wouldn't know that 0.99999 is there. You just get the 5. So we have a couple of example expressions up here that we'll talk through. We'll talk about when we might use this, and then I'll show you a very quick little piece of programming to take in two inputs and then print out the floor divider, just to show you how it might be expressed in code. So we have var a, which is 5 floor division 2. Right? So we're asking how many times does 2 go completely or perfectly into 5? Well, the closest we can get is 4, right? 2 times 2. So if I put in a print command here, we're going to do 5 floor division 2, and we'll run the script and we'll get that report here in a sec. Let's delete that and start over again so we can actually see. All right. There it is. Okay, so we got a 2, right? Because 2 times 2 is 4, and that's as close as we can get without dealing with fractionals or decimals or anything like that to 5. So let's apply the same reasoning to check out how var b would be evaluated. We're going to do, actually, you know what we'll do is we'll just do var b. That way I don't have to retype the expression. Okay, so now we have 10 floor division, which is marked out by 2 dividing signs. I should have said that earlier. 10, 2 division signs, floor division, 3. So how many times does 3 go perfectly into 10? Well, do the math in your head real quick. How close can you get to 10 without having to use a decimal? If you said 3, you're correct. We can get to 9, right? And I don't want to belabor the point or talk down to anybody, but that's roughly how this works. Probably you're used to calculating like this when you actually do math in your head, and then you spend a little bit of extra brain power there trying to work through or estimate how close you can get with your decimals. I know that's how I do the math. I try to figure out exactly how many times I can get the number that I want to divide by into the number that needs to be divided, and then I kind of peter through the remainders or the decimals to figure that out. That's how I do a lot of like financial calculations in my head when I'm trying to figure out how much is this going to cost or how long it will take to budget and save. That's my practical use case for floor division. Especially if I don't really care about the decimals or the change at the other end. I just want to know how many bucks is this going to cost me. So last one here, a little bit of a challenge. We have 47 floor division 7. How many times can we put 7 into 47? Let's run it and find out. Let's see if you're right. 6, right? Because 7 times 6 is 42. My dad taught me math decently. Can't say how much of it's been retained in the last like 25 years, but I have my multiplication facts down, right? 7 times 6 is 42. That's as close as we can get. The next increment would be 49, and actually, if we do it like this, you'll see it'll tick over to 7. Boom, there it is. Okay, so that's the floor division. When will we use it? Well, you might use it if you want to preserve that integer data type. If that's particularly important to you for some reason, maybe you don't want to deal with fractionals showing up inside of like a game loop or inside of a piece of software. You just need to know exactly how many are there. You might use floor division if you're looking for a specific pattern in numbers, maybe. You might use it if you are just doing a really basic budget and you don't care about the cents adding up, although Maybe not the best way to budget realistically, but you could do it that way, right? And here is an example usage in actual coding. So we have our while loop, which if you're watching the quick code videos, you're going to get used to it because I really like this structure. It lets me just keep testing something over and over again. Basically, while this condition evaluates to true, which the condition is just true, we're going to do everything inside or indented in the loop over and over and over again. In theory, until something changes this status true, turns it to false, but there's no way to do that in the piece of software that I wrote. This is an infinite loop, so the only way out of it is the kill button. So we have var e now, which is an integer that's input, and it tells you to type the number to divide. So this is the first number to the left of our floor divider, and then you have var f, which is an integer that is input. It tells you to type the number to divide by, so that is the number to the right of the floor divider. And then it's going to print out the result of the floor division, and we can take a couple looks at that. And as a bonus, because the modulo is kind of the opposite of the floor divider, I have it reporting that too, just as a curiosity for you if you like that kind of thing. So let's run it. It'll allow me to input down here way at the bottom. Let's say we do 15, and we're going to type the number to divide by is 14. How many times does 14 go into 15? We get 1, right? And then the modulo is 1 also, because there's only one more number remainder after that operation. But what if I do 15 and 4? Well, how many times does 4 go into 15? It'll be 3, right? And the modulo is incidentally also 3. Look at that. That's a little bit unusual, right? Because we go to 12, and then we have 13, 14, 15 gets us back up to 15, which is the number we were dividing by. We don't need to belabor the point here. I want to keep the video short. That is the floor division operator. It's got a bunch of different uses, but as with anything in Python, programming, tools in general, you need to actually put this thing into practice and get used to using it so that you can figure out when is the best possible time to use it. That's all I got on this particular operator. If you like this kind of head-first approach, you can do the doodad stuff, but I'm going to get going because I think I hear little feet on my ceiling.